Hello everyone, welcome to my YouTube channel. Today I will explain some more operations that we can perform on single linked list. If you are new to the channel, please do like, share and subscribe to my YouTube channel. And without further delay, let's get started into the video. The first operation that we're going to perform today is insertion at the beginning of the linked list. So how can we insert at the beginning of a linked list? For example, if I have some values like 10, 20, 10, 20, 30, 40 and then 50. Here 10 is my head, so I wanted to insert it head. So if my new node is 60, then I wanted to insert 60 at the head position, so I want 60 to be the head. Before doing that, if I directly do 60 as the head, we lost the link between 60 and this 10, 20, 30 and our linked list. So what we have to do first is we will link our new node to the head. That means we'll make new node dot next is equals to head. So immediately after doing this, what we'll do is we will make our new node as the head. Right now, even if we do this operation, our head is still 10, but our first element is 60. Head should be the first element, so we'll make our new node as the head. So head equals to new node. So let's implement this. Okay, let's create one more class. Public void. We are inserting at the beginning. Insert at beginning. We don't have to pass in any position, we just have to have one argument, that is data. So first we need to create the node to get inserted. So we'll create node, new node, equals to, there is one argument, data. And now I have to insert at the beginning. What I have to do, I will make my new node link it to the head, and then I'll make the new node as the head node. Let's go to the main.java and test the code. List dot insert at beginning of, we will insert like 0. Run the code, compile the code first. It is successfully compiled. Now run the code. So see, 0 is inserted at the head position. And one more operations that we can perform on a single linked list is inserting at a specific position. If I wanted to insert at specific position, then for example I have the elements already 0, 0, 10, 20, we don't have 30, 40, 50 and then 60. These are the nodes that we already 40 and 60. So let's see. This is my first 0th position, and then this is my first position. This is second position. This is position 3, 4, and 5. So for example, if my new node is 70 and I wanted to insert at position 2, then what I have to do? So I have to iterate until 1. I will iterate until 1. I will stop. If my position is 2, I will stop at 1. If my position is 3, I will stop at 2. If I wanted to insert at the third position, I will stop at the second position. For example, when I am iterating, let's take the variable current. So I will iterate until 1. Current is 10. So what I will do? I will make my new node dot next. I will link my new node to the second position, which is 20. So to make my new node into the second position, so new node dot next equals to my, I am at the first position. If I wanted to retrieve the node 20, then I will do current dot next. Then what I will do? Now I have linked my new node to the 20 element. Now I have to link 10 to the new node. So what I will do is current dot next, my current equals to current dot next. So I will make my new node as the current nodes next. So this is the main logic behind inserting at a specific position. And some more things we have to consider is when we are inserting at a specific position, we have to make sure we are not out of bound. If the user gave a position of 6 which is not available, which is not there, which is out of bound, only I have 5 positions, but the user gave 6th position, so it will iterate until 6, but we didn't find the element at the 6th position. There is no element, it is null. So if my current is null, if I am at the first position, for example, if the user give 6th position, I will iterate over 60. I will iterate until 60 and then I will be at the 5th position. Then we can insert at the next position. But if if the user gives the 7th position, that means I am at the 6th position. I will iterate until the 6th position, and at the 6th position there will be no element. That means there is no node at the position, so we can't insert at that position. So then we have to just return. So we have to also write the code to check these conditions to not get any runtime errors or to handle the exceptions. So let's see. Now create one more method, public void inserted position. So we have to pass in 2 arguments here. We have to pass the position and we also have to pass the data that we wanted to insert. So first we have to check if the position is 0. That means if we are inserting at the head position, then we can use the same logic. If position is equals to 0, then we just have to use the same logic. But we have to create the node first. If we are not inserting at the head position, then we have to iterate until position -1 and have to check current is not equals to null. and then we will insert at that position. So let's take the for loop. Before going into the for loop, to iterate over the linked list, we have to take a temporary variable. Let's take a temporary variable node. Let's name it current. Current equals to, we'll start from the head position. For int I is equals to 0, starting from the 0th position and iterating until I less than position minus 1. And one more condition we have to check is current should not be null. Current should not be equals to null. And then we have to increment the I. Okay. So now we have to move the current node to the next node. Current dot next. If we get out of this loop, that means there are two conditions possible, which is current equals to null, or either we have reached the position minus 1. So first check if current equals to null, then we'll just print a statement saying position out of bound. And then we just have to return. If this is not the case, then we reach at position minus 1. Then what we have to do, new node dot next is equals to current dot next. We are assigning the link of the current element to the new node. And then we have to make our new node as the next of our current. One thing that we forgot here is we have to create the node. Okay, let's go to main.java and test the code. So list dot insert at position of, we will insert at position 3 and we'll insert 30. So then the data should be in the order 0, 10, 20, then we should get 30 and then 40 and 50, 40 and 60. We will display compile the code. It's compiled successfully. Now run the code. So see, 30 is inserted at the third position. Now we will see inserting at the we will see deleting at a specific position. Yesterday we have seen deleting based on the value. Today we'll delete based on the position. And deletion at position. So for example, I have already have elements 0, 10, 20, 30, 40, 50, and I don't have 50, I guess. We have 60. We have 60. This is the end of the linked list. So now my head is 0, and let's say I don't want to create any node because I just wanted to delete the existing node. So if I wanted to delete the node at position 3, again I wanted to delete 30. So position is equals to 3. So what I will do, I will just have the logic. What I have to do is I just have to unlink 20 to 30 and link 20 to 40. Then 30 will be gone. There is no link to 30. Then that node no longer exists. We'll just link 20 to 40. To link 20 to 40, what we will do, we will iterate over the linked list until we will reach the position 10. Until we reach this position, and then we will link these two current dot next to will make this here. So one more condition that we have to check is, in the previous example, to insert at the position we have checked current is not equals to null. Here we also have to check current dot next should not be also null, because when we are inserting, I will be at this position. I will come till this. I wanted to delete this, so I will come till this position, and I will also check the current dot next. Here in the code, you don't have to check anywhere the current dot the next node, because we'll just immediately add, but to delete there should be a current dot next. So for example, let's see, I stopped at the position 20, like the position 2. I will iterate until 2. If I am now current, I am at the position 2. Current equals to 20. So if I wanted to delete 30, there should be current dot next. There should be current dot next. I wanted to delete current dot next, not current. So in the previous example, to insert, I wanted to insert. So even if that is not null, current dot next is null, I can insert at that position. Because I have the current element, like the position I am in, there is a node at that position. So even if the node after that is null, we can add our new node at that position. But if we wanted to delete, there should be an existing node. So we have to also check current dot next should not be equals to 0. Current should not be equals to 0, and current dot next should not be equals to 0. So let's see the implementation of this. Now create one more method, public void deleted position. To delete at a specific position, we just need to pass the position that we wanted to delete it, but we don't have to pass in any data because we are not deleting by value. Just pass the position. Now first I have to check if the position is 0. If the position is 0, then we can simply do as we have done in the yesterday when we are deleting with value. we will just move our head to the next node and then we will return. So if this is not the case, then we have to iterate over the linked list until we reach the position -1. I less than position -1, and also we have to check two more conditions, which is current should not be equals to null, and also current dot next should not be equals to okay. Why we are getting the error here? Because we didn't have the variable named current, so we have to create a temporary node current. We start from head to iterate over the linked list, and we have to increment the I. Okay, now we have to move our current node to the next node. Current equals to current dot next. Once we get out of this loop, what may be the conditions that made us to exit the loop? Either current equals to null or current dot next equals to null, or maybe we have reached the position -1. So let's check current equals to null and current dot next is equals to null. If current equals to null, or cannot use and here, because either any of these two conditions are true, we have to get to know that the index is out of bound. So current dot next is equals to null. So we used an OR operator here. This is not 0, this is null. What we have to do, we will just print position out of bound and then return. Okay. If this is also not the case, then we have reached position -1. Here comes our main logic, what I have already explained you. So what is the logic? Current dot next will be equals to current dot next dot next. That means we are linking my current element to the next element and the next element. We are just unlinking the element in the middle, so which is at the position. So let's go and test the code. Go to main.java. So list dot deleted position. So again we will delete at the third position. After deleting by this position. Now display. Let's see, there is no 30 here. 30 was deleted. Before I have 30 after 20, but there is no 30 here. That means 30 was deleted, which is in the third position. See, 0, 1, 2, 3 and 30 is in the third position and 30 was deleted here. That's it. Thank you for watching.